This problem is based on molecular term symbol. The question is, the first excited state of hydrogen molecule is, they are given 4 term symbols. Which one is correct? You may be very familiar with atomic term symbol, particularly for transition metals. It is given in this format. L is orbital angular momentum, S spin angular momentum, J it is total angular momentum. It is given by L plus S to L minus S. We have a similar representation for molecules also. Here we go for lambda instead of L. The spin multiplicity will be same. Here we go for either G or U. We go for parity, gerade and ungerade. Addition to that, we go for plus or minus sign represents the plane of symmetry, reflection plane in the molecule. Generally, we don't bother much about this. We go for only these 3. Now, let us see how do we calculate the 3 terms. That is spin multiplicity 2s plus 1. It is similar to the method whatever we follow for atoms. You have to go for the total spin. Each electron contributes off. So you have to add and you have to find out total spin. You have to substitute in this formula and you have to get spin multiplicity. Simply you can go for this formula also, n plus 1, where n is number of unpaired electron. If the number of unpaired electron is 1, the spin multiplicity will be 2. If the number of unpaired electron is 2, then the spin multiplicity will be 3. Next one, it is lambda. It is equivalent to L in atomic term symbol. This value may be 0, 1, 2, 3. Generally, we get 0, 1 or 2. 3 is very rare. If it is 0, we go for sigma term. If it is 1, we go for pi. If it is 2, we go for delta. If it is 4, we go for phi. In the case of atomic term symbol, if it is 0, we go for S term. If it is 1, we go for P term. If it is 2, we go for D and F when the L value is 3. You can find a similarity between these terms. This is sigma. The first letter is S. You can find that here. This is pi, Pi. So the first letter P you can find here. Delta, the first letter D is here. Phi, the first letter it is F. So you can find that here. So if you correlate like this, it will be easy for you to remember. Also, this lambda first letter is L. So this L also we use. Instead of lambda, we use L in atomic term symbol. The next one, it is parity. To calculate the parity, we find out the gerade and ungerade of the molecular orbital and we multiply them. If both the orbitals have gerade, then the resultant will be G. If both are ungerade, then also the resultant parity will be G. If one is G and another one is U, in such case we get U. This is similar to plus into plus, we will get plus, minus into minus, you will get minus, minus into plus, you will get, sorry, here plus, here it is minus. So a similar, instead of plus we have G, instead of minus we have U. So if you know these things, you can easily find out the term symbol for molecules. Now let us go for hydrogen molecule. They have mentioned first excited state. Two hydrogen atoms combine to give two molecular orbitals. This will be sigma, this will be sigma star. This hydrogen has one electron, this hydrogen also has one electron. So totally there will be two electrons. I have to place the two electrons here. This is the molecular orbital of hydrogen. Now they have mentioned it is excited state. So what I do, I excite one electron to the sigma star. In such case, what I get is one electron here and another electron here. So this is sigma and this is sigma star. So now I have to find out the term symbol for this particular arrangement. First let us go for spin multiplicity. 2s plus 1. There are two unpaired electrons, so directly I can go for triplet. Otherwise 2, the total spin will be 1, off from this, off from the other electron, so total will be 1 plus 1, so it will be 3. So this is how I calculate the spin multiplicity. The next one, it is lambda value. It is the sum of L value for each molecular orbital. To calculate this, you should know for sigma and sigma star, the L value or lambda value will be, generally we use this term, the small lambda will be 0. If it is pi orbital, the lambda will be plus or minus 1. In this case, we have only sigma and sigma star. So for this it is 0, for this also it is 0. So the total will be 0. When it is 0, the term is sigma. So whatever we get is sigma and the spin multiplicity is triplet. The next one, we have to find out the parity. In order to find out the parity, you should know the structure of molecular orbitals and the symmetry elements present in that. When you go for sigma molecular orbital, it will be something like this. Sigma star will be like this. Two s orbital combined to give this one as well as this. This is sigma, sigma star. In this one you have inversion center, but here it is not there. So here plus, the other side I have minus. So there is no inversion center here. If there is no inversion center, I have to say it is ungerade. When there is inversion center, it is gerade. So this as gerade, sigma star as ungerade. Now I have to go for the multiplication of this because the electrons are present in this as well as this. So G into U, so it is U, not G. Now let us go for the given options. There are two unpaired electrons. Because of that, the spin multiplicity should be 3. Here also sigma, here also sigma, so no problem. What about parity? Whether it is G or U. Since we have sigma and sigma antibonding orbital, it will be U, not G. So this is the answer, not this one. When I go for the excited state, the spin of the electron, the sigma antibonding may be like this also. In such case, the spin multiplicity 2s plus 1 will be something different. For this it is plus of, and for this it is minus of. So because of that, s will be 0 and overall we will get singlet. So there is possibility to get singlet sigma also. Not only triplet, we can get singlet also. When you go for the parity, it is G, this one U. If you multiply, you will get U. This option also has been given in the problem, but they asked for first excited state. So if you go for this one, this is possible, and the energy of this will be somewhat higher than the earlier one. So because of that, this is not the answer.